got to pump it up, don't you know? Pump it up. You got to pump it up, don't you know? Pump it up. You got to pump it up, don't you know? Pump it up. You got to pump it up, 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 don't you know? Pump it up. You got to pump it up, don't you know? Pump it up. You got to pump it up, don't you know? Pump it up. You got to pump it up, don't you know? Pump it up. You got to pump it up.
What up, Vigilantes? I'm really happy that you guys have tuned in into what I consider more than likely the most important interview that I will be conducting here in front of you guys, in possibly crypto history, to be completely honest. And the reason why is because we're going to be talking about the bit aspect of Bitcoin, something that a lot of people have known it exists, but no one's really like dabbled with it. And the two leading developers of the two leading implementations of Bitcoin Turing Completeness are here with us. Szabo Lu of sCrypt and Super Testnet of BitVM. Thank you guys both for being here with me. It's really an honor to have you both here.
Thank you, Rafa.
Awesome.
And
so,
yeah.
So glad to be here. Thank you for having us.
Awesome. So, yes. So what I want to get started is if you guys can please introduce yourselves to the audience and how you guys came to discover Bitcoin Turing Completeness.
Yeah, I go ahead first. So my name is Szabo Liu. I'm a founder of a company called sCrypt. So sCrypt basically is doing smart contracts, but it's not on Ethereum virtual machine, which I call it a Bitcoin virtual machine. So it actually can work on all the Bitcoin forks, including, I think it works, at the moment it works best well with Bitcoin SV, and it can also work with other Bitcoin derivatives such as Bitcoin Cash or BTC and Litecoin. So for me, this is our foundation for my company, because it shows, contrary to what most people, even in the crypto space, think, oh, Bitcoin can be, cannot do smart contract, or it has very limited smart contract capability. The Turing Completeness basically lays the foundation, says any smart contract other blockchains can do, or even any other computers can compute, Bitcoin, you can do it as well. So that says a lot of, basically is where the sCrypt come from, basically.
Awesome. Thank you for being with us, Szabo. Super. How did you get into Bitcoin Turing Completeness?
I think it probably started somewhere around the year 2017 with a video by Andreas Antonopoulos called Advanced Bitcoin Scripting, where he made this video going over how the Bitcoin stack engine works and showing you how you can create more complex Bitcoin addresses encoding logic. And I thought it was fascinating. I just really loved that video. And one thing that it seemed to be lacking in was software you could use. It didn't mention any software you could use to actually do this. Like I was left wondering, like, I can see how you could make programs using Bitcoin, but I don't see how you could, like, I want to actually make them. And I didn't know what software to use to do that. But over the years, I discovered some. I found that you could do it with Bitcoin.js. Bitcoin.js has support for Bitcoin script, and you can you can create scripts inside it, and then it'll run them. And then I found a couple of other tools for doing that. And so yeah, I started doing it. I thought it was really cool, and I started making cool programs, showing them off at like BitDevs and other Bitcoin meetups that are kind of developer focused. And eventually I met Robin Linus, who's the founder of ZeroSync. They've been trying to add zero knowledge proofing systems to Bitcoin. And we hit it off. So we made like a Telegram channel where me and him and a couple of other people tried to figure out a way to do zero knowledge proofs using Bitcoin script. And eventually what we came up with was BitVM. So which turns out it can do a lot more. It can actually run any program, which is pretty cool. So yeah, that's it all started with a video by Andreas Antonopoulos in 2017.
Awesome. Beautiful, beautiful. So how long has sCrypt been around, Xiaowei?
Yeah, sCrypt formally incorporated in 2019, but I have this idea, I also have a beginner video, which is different from Super Testnet. So you probably have heard about this 2015 video, now become famous. Craig Wright with all the, the all-star team, Nick Szabo and a lot of other so-called crypto experts. They're arguing about, whether Bitcoin is Turing complete. And all of the panelists except Craig Wright, saying, oh, of course it's not Turing complete, right? It doesn't have loops, So everybody knows that. But Craig is very, he's very persistent. It is, and he also explains the mechanism why it can be made Turing complete. And Nick Szabo even challenging him, saying, hey, if that's a very esoteric thing, maybe you can write some papers about it. And funny enough, he did write a couple of papers on that. So that's also the foundation for sCrypt. I read those, it's just for me, I happen to be a PhD in computer science, and Turing complete is one of those things, it's almost like a foundation for the whole field. So that's why I dive into the papers, and it just find, it's just fascinating because it's almost like saying, Einstein first came out with special relativity. Nobody believed him. Light doesn't travel in a straight line. Light can be burned. Or, it's just those things. I think most, if not all, people find strange, but which turned out to be proven later on. So I think this is one of the biggest, the foundational, I think, a paradigm shift for me. So that's when I dive into the script world. But then I found out, hey, as Super Testnet just said, there are not many tools out there you can build actually, useful programs with it. So that's why the sCrypt comes into play. It's basically a high-level language. You can compile to Bitcoin script, so you don't have to know all the script. It's very similar to like Ethereum world. You don't know about the EVM opcode. Instead, you program in Solidity or Viper or many other things. So it's pretty much like Solidity, but running on Bitcoin.
Okay, so for everyone that's in the audience, can you please both give us your definitions of Turing completeness? What does Turing completeness mean to be? Let's start there. This is, again, this is a very foreign topic for most people. So what does it mean for a computer to be Turing complete? And what does that mean for Bitcoin, for the Bitcoin protocol?
So I'll try first. So first, I want to give the formal definition. So basically, if a programming language or any kind of computing system is said to be Turing complete, if it can simulate any Turing machines. Okay, so that's the definition. If you look at the standard textbooks, for people who have not heard about Turing complete, Turing machine, it basically is some kind of like it's invented by the British computer scientist now. Is very famous now because of the Enigma movies. Anyways, Alan Turing, basically he invented this like hypothetical machine that you can compute any computable function or number out there. So basically anything that you can human can calculate, if you don't worry about how long or if it's efficient with a pen and paper, then basically a computer can also compute it. So that's a definite Turing machine. So in layman's term, so think about it, any program that computers can run. If any other system, let's say Bitcoin is Turing complete, that means it can run any program that your computer can run, or any other blockchain can run. So that's a practical definition.
Right on. Super. Could you please, do you have anything to add to that or define a little bit better, or maybe an example for the audience?
Yeah, I'd like to focus on what he said about the ability to compute or to run any computable function. Because I think that's what I tend to focus on in the definition of a Turing complete computer. It's one that is able to run any computable function. And you think of a computable function, what does that mean? Well, something like, I don't know, 35 plus 64 is a computable function. You can run that through a computer. It can calculate what the sum of those two numbers is and then spit out the result. But there are some functions that are not computable. For example, what's the last digit of pi? Well, pi is an irrational number. It doesn't have a last digit. And so a computer cannot compute that. So Alan Turing, the gentleman that Xiaowei mentioned, was a computer scientist in the very early days of computing. He made some of the first computers, and he wrote a paper exploring the boundaries of what these things he was making could actually compute. And he defined a theoretical model of a very basic computer that could, in theory, compute or run any computable function. And that's called a Turing machine. So yeah, that's most of what I would have to say about that. Yeah.
Okay, right on. So how is Bitcoin Turing complete? Who would want to take this answer first? How is Bitcoin Turing complete? A lot of people, there's been a lot of debates in the past, but I think the whole Bitcoin universe now agrees that Bitcoin is Turing complete. So how is Bitcoin Turing complete?
So I will try again first. So, for me, that's why how I started this is by reading, two of the papers by Craig Wright. So he has two papers out there that's being peer reviewed and accepted into, I think, pretty good journals. So you can definitely read out those. But after I read this, it's still a hole, in my mind. It's like, hey, these are very good theoretical papers. It's like you read, Einstein's special relativity, right? It's very good, in theory, but for me, I still, before I go there, do exercise, I really want to convince myself. I'm more like a, experimental kind of thing, guys. I want to, to put the theory into test. It's kind of like the British, the standard expedition team to, I think, near New Zealand when there's a sun eclipse. So they measure the sunlight, see if it's actually bent when it goes near the sun, and it actually bent. That's what I want to do. I want to, not just theorize about it. I want to write some code, and so I can convince myself. So that's actually what I did. So if you go to my blog, the one I put at the top is always how to simulate any Turing machines on Bitcoin. So that by definition, right, as I said at the very beginning, definition of a Turing complete system is you can simulate any Turing machine. So I just put out some example there, as a toys, Turing machine. But once you can implement that small toy Turing machine, basically it recognize whether a series of parentheses, whether they match, right? If you say a left, right, matches, right? What if you say left, but right, only one right bracket? It doesn't match, right? So, but basically the idea is once you can implement the one Turing machine, you can implement any Turing machine that same way. So by that, I think by experiment, I consider that's empirical evidence. The Bitcoin system is actually Turing complete. I think a funny anecdote, a lot of people that are questioning this, the paper and that. I think since then I put out the code and the article, is the Greg Maxwell of the world has not been attacking, Bitcoin for its Turing incompleteness. It's just less since the publishing of that article and code.
Okay, right on.
One of the characteristics of Turing machines is that we mentioned that they can compute any computable function, but they can also get stuck because one of the things they can't do is they can't determine in advance whether a program that you give them is a computable function. So you can give them a program that is supposed to calculate ever more and more digits of pi, for example, and run it through a Turing machine, and it would never come up with the. It would just keep running it forever. It would get stuck running this thing on a loop. And one characteristic of Turing machines is that in order to like run at very long times, if you feed a program into them that's very long, they have to have a lot of resources. In fact, in the definition of a Turing machine given by Alan Turing, his theoretical machine that could compute any computable function, he said it would need to have infinite memory. It would need to have an infinite amount of what they used tape at the time. They used tape that was divided into like cells where you would put data. And he said you would need an infinitely long tape in order for this machine to actually be able to compute any function. And no computer in the real world can actually do that.
Right.
We compensate for the fact that our universe does not have infinite resources by making as highly optimized things as we can, like ever more numbers of gigabytes of RAM in a computer, for example, so it can compute more and more functions as functions get more and more complex. But from that perspective, I would actually say it's not true that Bitcoin is Turing complete, or any other computer for that matter, or any other system. They can get as close as humanly possible. But since our universe doesn't have infinite resources, we don't have the ability to create, that infinite tape that Mr. Turing talked about. And so no computer is actually Turing complete in the definition. No real computer is Turing complete in the definition that Mr. Turing gave.
Right.
And
right.
Bitcoin's not either.
Like what I tell people when I try to explain this to people, I tell them like we understand the concept of like Plato used to talk about the universals, right? Like infinity, but we've never experienced infinity, but the concept is there, right? Like you said, we're limited in our world by limited resources. Thank you. Would you like to add anything else? How is Super? How is Bitcoin Turing complete? How is it a Turing complete machine?
Well, in the precise technical definition, I would say it's not, because no real world thing can be.
Right.
But it gets pretty close. And the reason why is because we found ways of expanding the amount of the amount of storage and capacity that you can actually use on Bitcoin to make it something that's feasible to do to simulate to run very large programs. One of the tricks that was recently made available to us, it came with the Taproot upgrade that happened in the year 2021. Bitcoin got an upgrade called Taproot, which allowed us to create very large scripts that have millions or billions of operations in these scripts. But what actually goes on Bitcoin is only a hash of all of that data. And that's actually what we exploit in order to make BitVM work. We make these very large programs that are all just what goes on Bitcoin is actually just a hash of the entire program. But with that, you can actually run any individual step of the program. You can say, okay, let's run, step 256 or whatever, step 5,753,000, and then you can run any program sequentially by just doing the individual each step one at a time, each step of the program.
Okay, awesome. Now guys, the reason why I brought Szabo and Super together is because they both are dealing with they're both experimenting within two different manifestations of Bitcoin, if we were to call it that way, right? So Szabo is working on BSV, Super's working on BTC. They both acknowledge that Bitcoin is Turing complete, what I've always called Bitcoin's computational power, the bit aspect of Bitcoin. And it's beautiful to see that this is actually taking off. And so your approach to engaging Bitcoin's Turing completeness is different. And so there is a lot of talk of looping and different types of loops. And so to take this conversation one step at a time, how does Bitcoin loop, Szabo? And then Super, if you could also explain how does Bitcoin loop in the Boolean sense of looping, Boolean looping. Xiaowei, how does Bitcoin loop? How does that happen?
Okay, so before even go to Bitcoin looping, let's say in general, how does a computer handle loops? Actually, for any computer, it doesn't have the concept of loop. It's a high-level construct, because if you look at the CPU instruction, there's no loop. There's no op loop, as far as I can tell. It has basic, operations on either numbers or bits. You can add numbers, you may shift some bits, but that's it. The computer doesn't, the CPU doesn't itself. The high level why you can give you a sense of looping is because it simply is very easy. Idea is, it's just, let's say you want to loop through some code, let's say 10 times. The CPU just redo the same thing again for 10 times. And then after it's done, it just keeps, goes to the next instruction. So that's how the loops done in a computer or CPU. Okay. So Bitcoin is also achieves the loops in a similar way, but in two, I could imagine in two contexts. The one is you can do in a single transaction. You can also unroll the loops similar to what the CPU does, right? You can unroll it. Let's say you want to repeat 10 times. You just duplicate, at the script level, 10 times. Then you can loop within a transaction. So that's one way to do the loops. Another way, which I used to prove the Turing Completeness, is an easier way to understand. Basically, you break up each iteration, and in each transaction, you only run one iteration. Right? So if you have 10, let's say loop 10 times, you simply have a chain of transaction, of 10 transactions. Each transaction just, iterate once. But also the tricky part is how do you make sure, this looping actually unrolls as if it's in the same transaction. So that's when we use some kind of like cryptography. I mean, in Bitcoin SV world, we call it the op push text. It's a technique, very elegant solution that's patented by On-Chain in, I think, 2017-ish. Yeah, that's the basic for this technique. But you can also do within a single transaction as well. But as Super said, in a practical system, the Turing Completeness is more like a theoretical concept, because if you consider the finite nature of all the resources that any given computing system runs on, either it's Bitcoin or C++ on your machine, it has a limited memory or CPU or storage, right? So in reality, it's only constrained by the size, by the artificial size of the, let's say, the script size or transaction size or block size. But if you make sure those are unbounded, the Bitcoin computation can also be unbounded. Here is a little different word. I prefer the word to use unbounded, not infinite. So that's my understanding of my way of interpreting how do you implement loops in Bitcoin.
Okay, awesome. Super. How do you guys go about doing it with Taproot? And I know you guys talk about Boolean loops. And so can you please comment, answer? Thank you.
Sure. And just to give a correction, a moment ago you said both Super and Xiaowei acknowledge that Bitcoin is Turing complete. I don't, because I'm going by the technical definition, in which no real world system can be until we figure out how to have infinite memory. We can't actually have real Turing machines. But I only say it's close enough. We can get close enough to where it doesn't really matter, because any program you can write isn't going to be larger than can fit in Bitcoin. Okay, so that aside, I want to talk a little bit about circuits.
Something just very important. Like when we talk about definitions like that, like I said, it's like the idea of infinity, right? Of course, we haven't experienced it, but we know it exists. It's almost like how many angels can dance on the tip on the pin of a needle, right? It's almost like, well, yeah. So there's the formal definition, right, to be able to compute an infinite number, right? And I mean, shit, man. I mean, when will we ever be able to achieve that technology, right?
But the nice thing is that no computer program we've ever written needs to compute an infinite number. They only need to compute numbers maybe in the trillions or quadrillions.
Right.
And we can do that, And so that's why I think it doesn't really matter if it doesn't meet the formal definition of a Turing machine, as long as you can go big enough that it does everything you might want it to do.
Yes.
Okay, so I want to talk a little bit about the concept of a circuit, of an electrical circuit, because ultimately, when you look at a computer chip, it's a circuit, right? They even call them circuit boards. So let's talk a little bit about a circuit, because a circuit sounds a lot like a loop. You take a circuit you create a circuit by taking some power source that usually has a positive charge and a negative charge. And the electrons on the positive side want to go to the negative side. They want to fill that vacuum, so to speak. And in order to do that, they will take the path of least resistance. So we create wires, which are conductors, and we make very complicated structures that allow an electron to go from the positively charged piece to the negatively charged one by passing along this wire. And while it's doing that, we can have it do stuff. We can modify where it's going. We can pass it through these things called logic gates. We can make it blink lights, because a light's just a resistor that glows when enough electrons pass through it. We can make it put pixels on a screen. And that's ultimately what we're doing, but it's not actually a loop. It seems like it, because you've got this power source that has a positive and a negative side, and it seems like a loop or a circuit because the electricity is going out from it and then back into it again. But from the electricity's perspective, it's not a loop. It's a straight line. They're going from the positively charged one to the negatively charged end, and they're going from their perspective in a straight line from one side to the other. So that's why we actually don't have loops. When you get down to the very basics of what your computer is doing, it's sending electricity from your laptop's battery, or perhaps some power station far away in your city, through a series of wires that end up lighting up some pixels on your screen, and they end up at the negatively charged end of some device. So we have to deal with that in Bitcoin. We have to design systems that enable the same thing. You don't actually have loops, but what you can do is you can set up a series of wires for these electrons to flow through, or in Bitcoin we use digital wires for these zeros and ones to flow through, that you line up in the series. So if you wanted to count to the number 10 trillion, you would probably want to add the number 1 over and over again to the previous number, and you do that 10 trillion times. So we line up 10 trillion wires. We line up 10 trillion wires for the electrons to flow through. And it's a very complicated circuit. It's a very long path from the positive charge to the negative charge. But those electrons don't care. It's still the path of least resistance for them. And so you end up with something on your screen that says, okay, I counted all the way from 0 to 10 trillion, but there was no actual loop involved. It was just passing through a series of gates, of logic gates, a series of a very long wire that went through a complicated series of gates and ended up going from the positive side to the negative side.
Okay, awesome. So, how is Super? Are you still with us? I think he has a cold, so maybe he's coughing. Did I guess right?
Yeah, no, I didn't cough. I sighed.
Okay. Okay.
I took a deep breath.
All right, right on. All right, so so I'm sorry, were you done with your explanation?
Yeah.
Okay, so how is a Bitcoin then Turing complete?
Well, it's not. It's just
but without obviously you already explained that it doesn't, no computer fulfills the 100% accurate definition, but within what we have in computer science, what we do call Turing completeness, how is Bitcoin Turing complete?
Right. So because Bitcoin understands all of the logic gates, and the logic gates are these very basic components that direct the flow of electricity. So that, for example, if you have a wire that's if your wire A is electrically charged and wire B is electrically charged, you can pass them both through this thing called a logic gate. And out of the other side, it'll check, okay, were both of them electrically charged? If so, then I'm going to send an electrical charge forward. And then you have other gates that say, if only one of them is electrically charged, then I won't send the charge forward. I won't pass the signal and let it keep going. I'll cut it off there. And so those logic gates that are the basic building blocks of all computer circuitry are things that Bitcoin understands. So what we do with BitVM is we take any computer program that you want to run and we decompose it, we break it down into its logic gates. We break it down into if you were running it on a real computer, what actual, how would the electricity flow to actually make this computer produce its intended result? It would have to pass it through AND gates, OR gates, NAND gates, NOT gates, and all these other different logical constructions. But Bitcoin understands all of those. Bitcoin can run each one. So we take the program, we decompose it into all of the steps that it would have to go through, and we make each of those steps available in a Bitcoin address, so that you can pick either any one of them and run it. And since you can pick any one step and run it, you can theoretically do all of them. You can theoretically do any combination, or even run through the entire program, and just have Bitcoin say, okay, I'm going to do step 1 first. And it's going to say there's a 0 and a 1, and it needs to come out as a 1. And so if you do that step, and then you can run the next one and say, okay, the next step, there's going to be 2 wires. It's going to be 1 and 1, and it needs to come out as a 0. And so you do that next step. And if you run through the entire sequence, you end up doing the entire program. But actually, with BitVM, we don't do that. We only run through the parts where 2 parties disagree. So 2 parties both have a program. They both say, okay, let's say it's an addition program. Say we're going to come up with 5 plus 60 and find out what the result is. If both parties say that 5 plus 60 is 65, then great, there's no need to run the program. But if there's a dispute, if one of them says it's 65 and the other says it's 62, then you need to run the parts of the program where you disagree. Maybe for the first 10 logic gates, they're all the same and there's no disagreement there. But then on the 11th one, mine came out as a 1 and his came out as a 0. And so then we'll put that one on Bitcoin. We'll say, hey, Bitcoin, run this one. And it'll side with, Bitcoin will side with one party or the other. And then that party is considered the winner, and they get the money.
That's awesome. Bitcoin, run this one. I love that. Oh, that's music to my ears, guys. Wow. Okay. So Bitcoin is a computer. Awesome. All right. So how is y'all's approach is different? I want to get into how is the sCrypt approach different to that of the BitVM, because I saw that Szabo wrote an article, or you rewrote an article where he's right now in BTC there is a proposal to reinstate an opcode called opcat, and I saw Szabo wrote an article that said you can use sCrypt and you don't need to reinstate opcat. So maybe we'll start with Szabo, since I brought him into him as this example. How, from your perspective, how is what you're doing different from what Super is doing?
Okay, so first to clarify, so in Bitcoin SV, so is basically the biggest difference in terms of so-called scripting capability is that in Bitcoin SV it restores. Okay, here's a keyword, restore. It doesn't add new opcode. Opcode is like is instruction set for the so-called Bitcoin virtual machine. Okay, it's an instruction set. So because historically it has been disabled, for various reasons we don't have to discuss here. But for example, opcat, as you mentioned, in BTC land is still disabled. And also, let's say opmap. Basically, you cannot multiply 2 numbers in BTC land today. Okay, but all of those opcode have been restored in so-called Genesis upgrade in Bitcoin SV, I think in 2000. So for us, we don't have that limitation. So the analogy I would use is, Bitcoin originally you can think about it as a Boeing machine. Right? It's a jet. It's engines, has wings, and has landing gears, all the stuff. Right, so you can fly at high speed. But then in the BTC version, it's almost like they take off the engines, and they maybe take off some of the electronics. But somehow, what's amazing to me, the Bitcoin BitVM, which congrats to Super here, they still managed to prove, hey, you can still fly. If it's a windy day, you can push it off like a cliff, and you can glide for a while. That's my analogy. While in Bitcoin SV land, we have all the engines intact. We have reinstalled the engines, the electronics, the hydraulics, the landing gear, everything. So, we are flying high in, the high speed and long range. So it's in machine capability. That means what we say is Turing complete. So that's the analogy I would use. In Bitcoin SV land, we enabled all the original capabilities. So we don't have any limitation versus on BTC land, because most of I wouldn't say most, a lot of the modern opcodes, for example, you cannot multiply two things, you cannot concatenate two things together. These are very basic, so which makes it very limited. But what the BitVM has shown amazingly, even given all these limitations, still can be also made powerful. So that's the difference between our approaches.
Okay.
Hope it makes sense.
Okay. Yeah. I like the analogy. Thank you. Super. How is what you're doing different than what Szabo is doing?
One difference is that we haven't re-enabled additional opcodes in Bitcoin. So we still don't, like BitVM doesn't use opcat and BitVM doesn't use opmultiply. These opcodes these instructions or functions that used to exist in Bitcoin, but that Satoshi removed. We don't use those because one thing that Satoshi left in, one thing he did not remove was he had left in support for all of the Boolean functions. All of those logic gates I was talking about earlier that are that your computer chip is in your computer is made of just a bunch of logic gates hooked up together. And since he left those in, we can emulate everything. We can emulate opcat. We can emulate opmultiply because Boolean logic gates, as demonstrated by your computer, they can run any function or any computable function. So yeah, that's one difference. And I suppose another difference. I don't. You can correct me if I'm wrong about this, Szabo, but it's my understanding that when a program runs using sCrypt, the entire program runs. Like you run the entire thing. And BitVM does not. In BitVM, you only run on Bitcoin the parts where two people disagree. Like I was talking about earlier, if you're adding 5 to 60 and you agree for the first 10 steps, then great. You don't need to run those. It would be a waste of time because you're just going to get the same answers for each logic gate. You only start running them when you disagree, and then you ask Bitcoin to pick a side. And in fact, even then, you only need to find one error. If you can just find one logic gate where you can prove that that the person who says 5 and 60 add up to 63, you just find one place where they made a mistake. You just have to run that one, and then you'll get the money that is in that Bitcoin address because you proved the other party made a mistake. So I think that is a difference, is that with BitVM, we try to run almost all of the computation off-chain, and only a single part where there's a disagreement it ideally goes on-chain.
Okay. So I think we're entering. Yeah, of course, yes. Of course, yes, you can comment. Well, that's what I was about to say, Szabo. Like, I think we've entered like 2 airplanes, right? You guys, we warmed them up. We got them going, and now you guys are both taking off on the tarmac. So at this point, I'm just the guy in the runway just waving you guys like, go, go, go. So now both, if you guys can just now freestyle. So just go ahead and freestyle.
Yeah, I thought you would be in the passenger seat, but anyway.
Well, sure, I'll be in the control tower then, okay? I'll be in the control tower, all right?
All right, so as I said earlier, so because we enabled all the opcode, so whatever BitVM can do, so we can also do. So we are like a superset. So that's just point one, because we have all the capability, right? You can also do the same thing on Bitcoin SV, right? Whatever BitVM does on BTC, you can do it better actually, because we have bigger script size and bigger the transaction and block size, everything, right? It's more capable. It's a superset. Whatever BTC can do, we can do it faster and cheaper. Okay. Even for BitVM, you can also do it, right? So for example, I can pretty much port because it's a subset. BTC is you can think about in terms of capability, it's a subset of BSV. So whatever you can do it there, you can actually do it here. Okay. So that number one. Number two is so the difference is, let's say, put an analogy. So in sCrypt, the way we prove, let's say Turing Completeness, right? For example, if you want to multiply two things, right? Two big numbers. In our way, we just do the multiplication directly. Okay, we compute it. Okay, versus the Bitcoin VM way, is you can do it, but to me, it's a little bit inefficient because of all the limitation, right? So you have to break it up. Even it's a single opcode, you can do the two multiply two big opmal. So you have to figure out all kinds of, let's say tricks.
Can you repeat that again? The last thing you said, you rugged a little bit. Can you please repeat that? Thank you.
Oh, sorry. Okay. So to analogy, I would use is, let's say you want to multiply two big numbers. Let's say 256 bits, right? It's like a Bitcoin private key, right? You want to multiply them. And then in our way of proving Turing complete, we just do the multiplication directly. We just compute it. Okay, because we have the capability. It's a single opcode. Versus if you want to do the same in BitVM, you can do it, but it's a little bit of let's say complicated. You have to first break up, all the computation, all the middle steps into logical gates, right? Even nano gates, in the paper. So you can do it, but it's not let's say as efficient. Okay, and also you don't compute it directly, as Super just mentioned. You actually, you only verify whether it's done correctly. If it's both parties agree, then there's nothing shows up on chain. I mean, you cannot even know that's a smart contract going on. But when people disagree, two parties, then they can challenge, the prover. No, the verifier then can challenge the prover to show where it fails, and then through some kind of economic, incentive, they can make sure it's penalized. So the prover has, whoever is doing the computation is economic incentivized. So the difference is very similar to like a roll-up world. So you have the two flavors, the optimistic one, and also you have the ZK, zero knowledge based roll-up. So in zero knowledge roll-up, you have a validity proof. Right? If it's accepted by the miners, it must be correct. That's similar to what sCrypt is doing. Right? So you cannot be on chain if the smart contract, fails. Versus the BitVM is more similar to the optimistic roll-up. So they have this fraud proof, right? So at the beginning you assume things are good, but then you also give a period for people to challenge if there's anything fishy going on. So then you can disprove it and then roll back. But then it has some trade-off, I'm saying. It's zero knowledge based versus optimistic. For example, optimistic, the fake transactions or invalid transaction can also be accepted before it was challenged. Or somehow reason, maybe the network is being DDoS. So the challenge never gets in. So even though the transaction is invalid, it also can be accepted. Versus us, whatever is accepted by miners, it must be correct to begin with. Okay. Thank you.
So I think I agree with all of that, except for possibly one thing. I agree that the way that the BSV is doing it is faster than the way that we're doing it in Bitcoin. Their airplane is more like a jet, and ours is more like a biplane. Ours is much slower than theirs. And I would agree with there are a couple of things I would say. Is it more efficient? In one sense, what they're doing at BSV is more efficient, because that's what makes it faster. They're not simulating multiplication by doing every single logic gate step. By simulating that, they're actually just running a multiplication application, and then a much faster computer can can run that really quickly, can run those logic gates. So they're doing it more efficient in that sense. But in another sense, BitVM might be more efficient in that what we do in BitVM almost all stays off chain. Like you're not putting all of these logic gates on Bitcoin, and you're not asking Bitcoin to evaluate every one of them. You're just doing one, only if there's a disagreement. And so, in a sense, that makes it more efficient. What we're doing.
Oh, can you do that on BSV as well?
Yes, you can.
And cheaper and faster. Do the same thing. That's my point one, actually. Yeah.
Okay, so I have a question for both of you. When you compute something on chain, you're also obviously having to pay transaction fees, right? Obviously, right? Because you said cheaper.
Yeah, because it's a transaction, so it has to pay a fee.
So economically speaking, the transaction fees, how much is a transaction fee in BTC right now? Super.
Right now, I think it's like 60 cents, but like recently, it was as high as $30 within the last 2 months.
Oh shit! And how expensive is it on BSV right now?
It's 1 sat per kilobytes, so I think it's 0.0000001. If I've done the math, but it's close. It's millions of times cheaper, at least, and it's becoming even cheaper as we go, as we scale.
Okay. Damn. By doing the computations off chain, Super, do you save in the cost?
Yeah, because if you had an addition program, and let's say that it had 30 steps in order to add two numbers together, or let's say you were doing multiply and it had 150 steps to multiply two numbers together. If you did it all on chain, at least with our model where we're emulating multiply by doing each step of logic, you'd have to do like 150 transactions in order to multiply two numbers together, and so that'd be ridiculous. So we only pick, we have two people run it off chain, and if they agree, nothing goes on chain. If they disagree on the computation, then they find one step where they disagree, and they say, here's where the disagreement is. Let's have Bitcoin run this one step, one transaction, and then it picks a side. Bitcoin says, okay, this guy got it wrong and this guy got it right. So yeah, that's what we do. And on the BSV side, they do have the multiply function. So it doesn't take them it wouldn't take them in any circumstance 150 transactions to do a multiplication. It would just take them one, because they have the multiplication function, and ours does not.
So like what I've noticed in BSV is that they're even because last time I checked, it was like 1/30,000th of a penny to post and list things for sale. So the community started subsidizing things, and shit, man, for like $20 you can do like subsidize millions of postings and listings of things for sale. So my mind is being blown right now, because that means that in BSV we can do the same thing as BitVM. For privacy, if someone wants to create something that wants to compute off chain, fair enough. But you can also run a shit ton of computations that the community can subsidize and can offer it to the world for free. Am I reading this shit right? Is this pretty much what I'm getting at? That any computer scientist can just start computing shit on BSV right now, and maybe people can just subsidize like $100 and just like subsidize millions of fucking computations on chain. Am I reading this shit right, Szabo? Or am I fucking going crazy here?
No. I mean, that's what people have been doing,
Okay, so what's I'm gonna have to ask a question then. A little contentious. Is BTC the testnet for BSV, or is now BSV the testnet for BTC? What's going on here? Or are you guys gonna? Because what I feel like is gonna happen is that you guys are gonna end up having a symbiotic relationship as the market figures it out. So it is really an honor to bring you both together. Have you guys met before? I'm just curious.
No. In some of my past projects, I've looked at the stuff that sCrypt has done, and I've taken inspiration from a lot of the demos they've done. I've tried to do the same thing that they do on BSV, but do it on Bitcoin. So I've used a lot of their resources they've created, but I've never actually met Xiaowei. So good to meet you, Xiaowei, or digitally meet you.
Okay. Nice to meet you here. Thanks for the opportunity, Raphael. Yeah, I think it's because Sims is the super priority privacy focus. I have not met him in person. We just briefly, I think, exchanged DMs after he launched BitVM. Yeah, thanks for the opportunity.
Yeah, for sure. No, I'm not trying to end this conversation at all. I want to go as long as we can to really dig into all of this. And the audience watching,
I certainly hope that, as you mentioned earlier, you said that you hope that there is a symbiotic relationship. Well, yes. I certainly hope that as well. And
100%.
So far, it has been. You know, like I might not have been able to do BitVM if it hadn't been for the work they've done in sCrypt, and I hope that that continues. That they put out more good work, and then we can try and do similar things on Bitcoin.
All right, so this is a way left of the field question that just came to me that I have to ask you both, and we will get back into the conversation. But with the uncertainty and problems that are happening with the Lightning Network and layered scaling, I want to propose a solution here, guys. All right, I humbly want to propose a solution. What if Bitcoin, if we just can, you know how they say the solution for everything in Bitcoin is Bitcoin? What if the solution for layered scaling and, is within Bitcoin itself? So what if the solution for layered scaling is BSV, to be the microtransaction, nanotransaction chain for BTC? What if? I mean, that sounds like logical to me, because you're using the same SHA-256 miners, protecting and overseeing both networks. And voila, you have your cake and eat it at the same time. And I hate to put this, but you see a lot of cross-pollination already happening. You see that all of the top ordinal marketplaces, actually the top ordinal marketplaces in the world, Ordinals Wallet, Unisat, OrdSwap. The first one was OrdSwap, by the way. They're all BSV teams that came into BTC the moment that Casey Rotomore dropped the white paper. So I already see the symbiotic relationship, man. So why can't BSV be the quote unquote second layer that BTC needs? This just makes sense to me right now. What do you guys think about that idea?
Xiaowei, you want to go first?
Yeah, if you don't mind. Yeah, by the way, thanks for the compliment. I didn't know, BitVM is very familiar with what sCrypt is doing. So that gives me more, inspiration.
You're rugging.
Put out more public works.
For a second there, you were rugging, but you're good now.
Oh, you're good now. Yeah, I will keep doing what I've been doing. Thanks for the compliment. I think that the BitVM also give me some good ideas, like optimistic roll up. You don't have to run everything. So thanks for that. So coming back to your question, I think definitely yes. There are a lot of people. I would say most people in so-called two camps. They're maximalists in their own coin. So I'm more flexible. Even I'm mostly focused on Bitcoin SV. I look at all the chains such as BTC. If there's good ideas like Ordinals, I just port it over, no problem. And what you have mentioned is it's an intriguing idea, and it's also very straightforward Sims, right? Because if one chain has a bigger market cap and more attention, let's say, liquidity, and versus another one is more technically capable, but not many people know about it. It can of course act as whether you call it a layer 2 or some people may call it a side chain. Yeah, no problem. Actually, I know quite a few people, they are trying to build this bridge, so-called, two-way peg or whatever you call it, a bridge to convert BTC assets into wrapped tokens. For example, BTC, you can have wrapped form on BSV, take advantage of the low transaction fees and fast confirmation, all the smart contract capability. Then after you do all the transfers, for example, you can do all kinds of things here. And once you are ready to go back, you can pack into BTC. I know at least two teams that are already actively working on this. Yes, so it's a good idea. for the symbiosis. Yes.
Awesome. Good.
Yeah, and I'd like to focus on that bridge thing that he was just talking about. One thing that's been limiting the ability of Bitcoin to work with or to have a symbiotic relationship with other blockchains is the difficulty of having two different monies. One money to pay fees on the other blockchain, and then somehow get Bitcoin over there and use Bitcoin as like a second token on that blockchain. And I think it's possible that BitVM might make that easier. It might make it easier to build a bridge from Bitcoin to BSV, for example, so that people could take one Bitcoin, peg it into BSV, and then have some kind of confidence that it'll still be worth one Bitcoin when they're done using BSV. So I hope we can do that. There's still some unsolved problems in the way of doing that. But the other difficulty with it is that, at least in the way that bridges currently work, there's a bridge between Bitcoin and Ethereum through the BitGo company, where you give them your coins and then they give you a corresponding amount on Ethereum. In that model, you're still using Ethereum as the token to pay for gas fees. And I think there's an unsolved problem there. I think it would be an improvement if you didn't need the Ethereum token for that. If you could just use, if you could just put Bitcoin onto Ethereum and then use Bitcoin to pay for your transaction fees. And I'd like to see the same thing happen with BSV. But that's like an unsolved problem. I don't currently see a solution to that. So yeah, there's still some work left to do before I could be confident in using such a peg or such a bridge.
Awesome.
Yeah, I'm really rooting for you, the BitVM team, to solve this trustless bridge, because then it allows you not only to peg out. I think this part is solved as far as I can stand. From BTC to BSV is easy, but then the pegging, because of the disabled script and script limit size, so it's not as trustless as one could wish. For now, you still have either use trust some centralized parties like BitGo, or use some kind of like a federated system, which is like
Xiaowei, you're rugging again.
It would be
You're rugging, Xiaowei. Yeah, you're rugging, man. You keep rugging. The last thing we heard. Yeah, the last thing we heard was federated system.
Oh, federated, which is essentially a multi-sig. So it will be ideal. We can make this trustless. So make chains they can, talk to each other, without trusting any third party.
And I think the beautiful aspect of this idea is, like, in the Lightning Network, you find people already having to, throughout Lightning history, having to say, well, we're going to need some sort of watchtower, right? That's been a solution for their routing problem. But all of a sudden here, it's like, here's a solution. What better watchtower than the Bitcoin miners themselves? Like, just secure both networks, right? Like they already do. Those Bitcoin miners. I'm a Bitcoin miner, and I mine across all three chains. Why? Because
See your logo.
Yeah,
logo.
I'm mining, baby. Why do I do that as a miner? Because for me, they're all future networks that are working on providing me future value. So why it's stupid for me to only, it's like saying, well, your company, I'm trying to find the right analogy, but in reality, it's like, why would I just support, if I have an inheritance, if I can have 3 children and they can be very good at taking care of my inheritance, why would I just, be happy with just one? You know what I mean? No, I like 3 as a miner. So as a miner, right now I have 3 children and I want to protect them all, because I don't know, what may happen in the future. So I would love for my children to start working together. And that's kind of to be honest, it's really what I hope you both do. And it seems like this conversation maybe could lead to something like that, which would be beautiful, right? That symbiotic relationship. So thank you both for your generosity in that. That says a lot about this Bitcoiner spirit, right? That we're called to really look after one another and what's best for each other, just as miners look out for what's best for everyone in securing the network. So now I want to get back into looping, Turing completeness, and all that. I have a question for Xiaowei, and it has to do with privacy. So when I started really geeking out regarding sCrypt, because I'm a privacy enthusiast, for example, Monero uses one type of zero knowledge called bulletproofs, right? There's also ZK Starks, ZK Snarks. And then I read in one of your papers, Xiaowei, you were like, oh, we could run them concurrently on chain. I'm like, what the fuck did I just read? Concurrently on chain. And then I asked you in person at a conference, and you told me, yeah, we don't have to be married to one type of zero knowledge. We can have like different applications running different types of zero knowledge at the same time. And I'm like, wait a fucking minute. And these conversations can happen on chain. So yeah, and like that fucking blew my mind, bro. And then also the whole notion of recursive inscriptions. Maybe you can explain that better to me, and I would love to hear super comment on the area on what I just explained regarding privacy and using different types of zero knowledge on chain and what that means, and maybe we can get into like privacy, right? Have a privacy conversation here.
Okay, it's great you bring this up, because that's the beauty of Turing Completeness, where it comes from, right? Because before I even start implementing, let's say ZK Snark, I'm very sure it can be done. Why? Because the Bitcoin system is Turing complete, meaning any computer program or any algorithm, you can run it. So even before I start coding the first line, I know it gives me confidence. This definitely can be done. And then the detail is just an engineering issue. So actually we implement ZK Snark, it's cost about, I think 0.000. You don't have to, it's probably like a fraction of a penny, especially now. And the beauty of this is because it's Turing complete, you don't have to be, as you said, you don't have to be bounded. It could be coupled with one specific zero knowledge, right? Because different flavors, they have different trade-offs, right? Some have trusted setup, some have smaller proof. For now, we don't have one proof system that has the best of all these dimensions. So pretty much depends on use case. You have to choose and pick and choose. But for Monero, Zcash, for a lot of other chains, they have to find one, or maybe two or three. Bottom line, they only can hard code into the consensus layer. But because Bitcoin is Turing complete, right? So for us, we always implement this in script. So that's the beauty of it. I think now you can understand. We don't have to, because in reality, it's very hard sometimes to pick one algorithm that satisfies every use case. For us, because it's programmable, so you can program anything you can imagine and put it entirely runs on chain. That's actually what we have done.
Fucking fascinating, bro. Like mind blowing right now. I know I read a comment by from Robin Linus, and he said that one of the main reasons why he's doing this is for privacy on Bitcoin. Super. I would love to hear your comments, your take, your observations on everything that Xiaowei just explained, and maybe juxtapose that to what it is that you guys are doing with ZK within BitVM.
Sure. Well, to start with the last point, we're not very close to having ZK stuff in BitVM yet. What we've got working right now is we've got an addition function that works, and we've got a function that can count the number of zeros in a string. That works. And we've got a function that can compare the size of two numbers. We can say the first number is bigger than the second number, or vice versa. So that's the only things that we have working currently in BitVM, and it'll be a long way. I suspect it'll be a while before we get zero knowledge stuff working in it. That it takes a lot of building up functions and writing functions in this programming environment that before you can have really fancy toys. And right now we've only got very simple toys, so there's a lot of work to be done in that direction. So that said, I was listening to Robin earlier today in his segment he did on the Ordinals show, in which he said that he thinks he will have a new version of the virtual machine by the end of next week that will be more flexible than what we currently have, and will actually have a programming language for it that is better than what we currently have. So perhaps this will move faster than the speed at which it's currently going. But at the current pace, at the pace at which I can work, I think I could have some kind of zero knowledge proving system built out on Bitcoin within a year. And so that's what I'm confident in saying, that I think I could do that. But Robin's also working on this, with a separate team from me. And so he might be, it sounds like he's much further ahead than I am. So I'm really looking forward to see what he comes up with end of next week, so that hopefully we can get this stuff built out more quickly.
Right on.
But I also, Xiaowei also mentioned that it's good to have multiple options. And I totally agree. I would like to see ZK Snarks, and bulletproofs, all of those. And I don't know a whole lot about the zero knowledge space, but I would certainly love to see more of that, more protocols using them, and then let people pick which one they like best and which one gives them the best privacy.
Okay. So when you guys implement zero knowledge on BTC, will you guys have to be married to just one type of zero knowledge? Or could you also have the multifaceted, the optionality that BSV has?
Yeah, we'd have the same optionality, because the BitVM machine can run any computable function. So as long as there's a function for it, you can convert it into the format that BitVM understands and run it. So whichever one, so we can have all three. We can have all three types of cake, and then let people pick their favorite flavor.
Okay, cool. Thank you for clarifying that. Freestyle, guys. Whatever you guys want to say. Talk.
Literally Turing complete. That's what it means. You can implement any computable function you want. Zero knowledge, encryption, anything you can think of. I think that's also
just with the caveat that within the constraints of having limited amounts of resources.
Yes, always as a practical system. So I would want to add into that, because Raphael, I know you are like a big into the privacy going. So there.
Me? No, Bitcoin, never. Not me. I just comment about it. I just talk about it. I'm very geeky about it, but I'm all into Bitcoin. I'm a Bitcoiner. I'm a Bitcoin maximalist. Unsplit UTXO's Bitcoin index, baby, right? You guys duke it out. I'm just an investor. So when the civil wars happen, I just sit back and I'm like, okay, let's see, whatever, right? And as a miner, okay, well, I'll take care of all three. Let's go, right? That's been my philosophy. I still hold that philosophy. So I think of myself as an extreme Bitcoin maximalist, okay? But on the side, I think Monero's cool. I think Darrow's cool. I think Pirate Chain is cool, yeah.
That's what I'm saying. Because of the Turing Completeness, you can implement these functions. You don't have to run another network, another blockchain. You can put this, whatever features you want, you can program them and run on Bitcoin. So then you can leverage all the tools, right? Instead of everybody runs their own chain, we'd better unify as one chain.
One of the tools that we have for privacy in Bitcoin is this transaction type called a coin join, in which a bunch of people create one big Bitcoin transaction, and they all put like a Bitcoin in, and they all get a Bitcoin out of it in like random addresses that no one's ever seen before. And this is one way that we try to achieve privacy on Bitcoin. But I really would like something like Tornado Cash on Bitcoin. So Tornado Cash is this protocol that works on Ethereum, where you can deposit money into an address on like Monday, and then on Thursday you can come, pick up your money. It's been totally cleaned. It's like you dropped it off at the dry cleaners and picked it up again. It's in a new address no one's ever seen before, and there's no link between the money you put in and the money you take out. And I would love to build something like that on Bitcoin. Once again, there are unsolved problems that I don't see a current solution for, even with BitVM, in order to do that. I guess with BitVM, I do see a path towards it. So that's one of the things I hope to build with it is make something that is, I think that's better than a coin join, because in order to do a coin join, everyone who wants to be involved in it has to be online at the same time. Or if they're not online at the same time, then you have to wait. Be like, okay, there's going to be 30 people in this thing. We're all going to put a Bitcoin in, but Jerry's not online right now, so we got to wait for him to come online so we can do it, or you got to kick him out. So I think Tornado Cash doing something like that would be better, because you don't need that level of interactivity, and you don't need to wait. You can just drop your money in, come back later, pick it up, and you're good. And you can even do that on like a cell phone. Whereas with a coin join, it's a lot harder to do that on a cell phone, because it's like you have to keep it running the whole time and stuff like that. So yeah, I'd really like to see something like that built out.
Okay, super. So the privacy enthusiast in me and the Monero community would like just get mad at me if I don't ask. Like, if someone really needs privacy, then why don't they just go use something that's already working, that's default at the protocol level? Because it seems to me that anytime you would use the big problem that I see, and I'm going to use the language that you guys use at BitVM, is the issue of making sure you leave as little on-chain footprints as possible. Fair enough. I see the motivation. Cool. But the thing is that like with blockchain analytics, with there's more and more funding of blockchain analytics. And I'm not just concerned trolling here. This is, it's like at Bitcoin. Okay, so one of the main reasons of the Bitcoin civil war for people watching was that BTC and Bitcoin Cash both wanted Bitcoin to be a privacy coin, be fungible digital gold, digital cash, right? The Monero community said, well, it's not going to work here. We'll just start from scratch. We got the crypto note white paper from Nicholas von Saberhagen, and that's the privacy coin world now, right? Being led by the Monero community. And so it seems to me that sure, like I can see a use for privacy within any of the Bitcoin protocols, competing chains. But I honestly can't see Bitcoin being fungible digital gold, digital cash like Monero on any Bitcoin implementation, on BSV, Bitcoin Cash, or BTC. It's just, for me, as a privacy enthusiast, if it's not private by default at the protocol level, it's not private at all. But I do see use cases where, for example, I send the data packet across BSV that has a recursive zero knowledge proofs, right? So it's like a proof within a proof within a proof within a proof. To the outside world, they'll just see a packet move along this new internet called Bitcoin, but only those who hold the keys on both ends know exactly what's within that zero knowledge box. Fair enough, that's cool. We can go dispute the ownership of that box, even to an arbitrator out in the open. Heck, there could be like the whole media can be involved. Such person wants to like sue this other person because of some transaction that happened on the Bitcoin blockchain, where like you have there's something in this mysterious black box that costs hundreds of millions of billions of dollars, and you can dispute that. You can take it up to some court, and they can say, oh no, the owner of this box is so and so, and they get awarded the money, whatever. And at the end of the day, everything was public. It happened on a transparent protocol, on the Bitcoin protocol, but the content of the data on chain is secured by zero knowledge. See, that's where I see zero knowledge and privacy making sense within a transparent protocol like the Bitcoin blockchain. It's just, that makes sense to me. But it does, like, to be completely honest, Super, it doesn't make sense to me to try to figure out sound digital gold, digital cash on any of the Bitcoin chains, because you will always have at least some sort of probabilistic analysis that can tie in both ends of a transaction, right? Sure, a lot of people that are trying to work with privacy within BTC, they're they're counting on the laziness of bureaucracy. Last time I checked, crypto exchanges check back and forth 15 hops. So they're like, well, if we do a whirlpool for like 150 blocks, we'll be fine. There would be no red flags of what could be possibly a tainted coin. And so how is it doesn't make sense to me, Super. Like, please explain to me, how can you try how could you make Bitcoin private using zero knowledge proofs after from what I understand, it's just you're never going to be private by default. And like, if anything, if you have optionality within a blockchain, like we saw with Zcash, 0.06% of the people within Zcash were actually using the Z addresses. Everyone else was just happy. So, but probabilistically, you knew like you can figure it out through blockchain analytics. So, and that's why something like Pirate Chain is so revolutionary, because it's like, okay, Zcash, but by default at the protocol level, Z addresses for all, anonymity set of like 500 million or some crazy shit like that right now with Pirate Chain. So that makes sense to me, right? Monero makes sense to me, right? That makes sense to me. Everything is the same. Fungibility, using ring signatures, the whole shebang. Ring CT, ring signatures, confidential addresses, all of that good stuff. Cool. And now they're going to add even more privacy, right? Within Monero. Cool. That makes sense to me. Trying to do it on Bitcoin, on BTC, that doesn't make sense to me, man. So help me understand what you guys are trying to achieve here with zero knowledge using BitVM in an attempt to make BTC private when I don't see ever being capable of being private like a Monero. Because if I really care about privacy, if I'm in a do or die situation, I'm gonna go use something that is like dog shit simple to use, man. I'm gonna turn up and use a Darrow wallet. I'm gonna use a Monero wallet. I'm gonna use in a 1930s Germany situation, I'm gonna use a Pirate Chain wallet. I'm not gonna be putting myself out there to possibly fuck, man. It's just it doesn't make sense to me. Zuper, help me understand this. What's going on?
Sure. Yeah. I think it's not good that we live in a world today where people are using two different monies for two different things. And let me give a couple of examples. Some of the people I know who like Monero say that there are a few things they really like about BTC, and one is that it's a very simple protocol. Another is that there's more people running Bitcoin nodes than running any other cryptocurrencies network. It's got the highest degree of decentralization, the longest, the prospect of lasting the longest. They like, some of my Monero friends like all those things about Bitcoin, but then there's something they don't like, which is that it publishes all of your data.
Actually, a lot. But a lot of Monero guys, for a lot of the points you said, just to be fair here, they would disagree on a couple points you made there. Just letting the audience know.
Sure. Yeah. You get 10 people together, they'll agree on 5 things. Maybe 3 things.
RandomX does make Monero more decentralized because they're ASIC resistant, right? So one CPU, one vote. That is the mindset of the Monero person, right? That they're following Satoshi's original design in their mind, where one CPU equals one vote. Therefore, you should be able to, mine on a laptop, on a GPU, right? That's the Monero mindset. It's taking the small blocker argument for digital gold and digital cash to its ultimate conclusion that if it is that what you want, digital gold and digital cash, then you have to have true decentralization, and that's why RandomX is what the Monero, which is ASIC resistant, because they're scared of mining. Shout out to Valnero, because they even went even further, and now they're like the mining pools are even more decentralized within Valnero. Sorry to cut you off there, Super. It's just, again, a lot of my audience are hardcore privacy people. If not, that's like the core of my audience here. You know what I'm saying? So I'm sorry I have to.
Sure.
make those
Yeah,
comments.
so I don't know a whole lot about RandomX, so I don't want to speak from a position of ignorance here and try and make a comparison. So I'm just going to not talk about that because I don't know about it. So sorry, but the point. Let me continue with where I left off, though. I don't like that we have to have two monies, like one that's actually has decent privacy and another that is Bitcoin. I would prefer to have one money that has really good privacy and has all the properties that make Bitcoin great. So from my perspective, you've got two options if you want to get there. You either take Monero and you make it a better money than Bitcoin, or you take Bitcoin and you make it as private as Monero. Well, the Monero people are doing a great job making Monero better money. That's what they're working on. They're on this project. They're making it better every couple of weeks. And then you have the people on the Bitcoin side. How are they doing on making Bitcoin more private? Well, I think there's a lot more work to be done there. I think there's a lot of failure in trying to make Bitcoin more private. So that's something where I think I can contribute. I've got some ideas for how to make Bitcoin more private, and so I'd like to do that because I personally think it'll be easier to take Bitcoin and make it private than to take Monero and make it good money.
Right, but the thing is that it's a lot harder to change infrastructure than it is to change liquidity and perception. So I don't agree with you. I'm being honest, I don't agree with you. Infrastructure is a lot harder. And if I want to, if I want to use sound digital gold, sound digital cash as defined by, the small blocker, a worldview, then I'm going to use Monero. I'm not going to, it's like what you guys are trying to do has always been like trying to change a semi while it's flying at 120 miles an hour down the highway, trying to change the wheels. It's like, whoa, dude, yeah, theoretically it's possible, but holy shit, man, is that dangerous? It's like, and when it comes to like people that need privacy, it's like, bro, I don't, I want some things, I want things that are easy, man. And it's very important, guys, to mention that this was like really at the heart, the underlying premise of the Bitcoin Civil War. And believe it or not, the Monero community tree of logic is the same tree of logic as the BSV community. Let me explain. The Monero community has this premise: Bitcoin will never be private. Therefore, we should start from scratch. Fair enough, cool. BSV has the following premise: indeed, Bitcoin will never be private by default because it wasn't meant to be private by default. It's supposed to be a truth ledger, an honesty machine, the book that can never be burned in an age of fake news, shadow banning, in the age of AI and deep fakes where there's noise and you don't know who to trust. We need a truth machine. So the BSV person, the big blocker said Bitcoin is a truth machine for everything, and that's why they reignited all the opcode. They made sure that after the Civil War, they reignited all the opcodes and they turned everything that Satoshi gave us back on, because they saw like Bitcoin. They took Bitcoin in everything that Satoshi gave us. It's like, wow, okay, now let's go fuck around with that. Like, let's not try to impose our will on it and try to make it into something but let's try to figure out what it is that Satoshi gave us here in its totality, So a lot of the Bitcoin Civil War then turned into Bitcoin Cash and BTC saying, we want to focus on the coin aspect of Bitcoin, just the coin aspect of Bitcoin. Don't pay attention to the bits aspect of Bitcoin, because paying attention to the bits aspect of Bitcoin is dangerous. It's so dangerous that it can hurt our ambitions of turning Bitcoin into something like Monero, because that's exactly kind of like what BTC, the small blocker world, and Bitcoin Cash has always wanted. Something like Monero, digital gold, digital cash. So I consider the Monero community as like the fourth fork, but not a fork, because they just were Bitcoiners, OG Bitcoiners that said, we need to start from scratch, man. If the motivation that Bitcoin Cash has and the motivation that BTC has is correct, and obviously it is, because there's a need for sound digital money in the internet, then let's not even fuck with this protocol anymore. Let's start from scratch. And that's what the Monero community is about. The interesting thing is that the BSV community agrees with the Monero community and says, indeed, you should start from scratch because this is not the place to do it. This is the place to maybe use privacy the way that I explained, where, you know, I gave the example of the court case of that secret box that no one knows, but it's highly televised because it's a secret box, but it makes sense, but it's still within a truth machine, an honesty ledger, right? A book that can never be burned, which in my opinion, honestly, guys, I'm a big fucking privacy enthusiast. Like, I'm a co-founder of the Crypto Vigilante, dude. Like, I work with Jeff Berwick, dude. Ed Bugos, right? The Golden Lantern. So I understand privacy very much. But let me tell you guys something. Like, for me, watching what the fuck is going on in this world right now, like we're at the verge of World War III. What we need most is a truth machine, man. A truth machine protected by proof of work. And so that's why my motivation is really to bring you guys together. Hopefully you guys can work together, because in my opinion, guys, sincerely, I really think we need to achieve hyper-Bitcoinization as fast as possible. We cannot be, humanity cannot afford to wait another 18 months. I'm sorry. I know that's a meme. People don't like to hear it. I'm a BTC investor. I hold Bitcoin since before the Civil Wars, dude. I came into this bad boy like in 2011. So like, I'm a Bitcoiner, dude, and I'm sick and tired of all this bullshit. So how about we start working together, yeah? Because like, we need hyper-Bitcoinization now, and it is possible, guys. It's possible, and it's starting to happen. Like, what I've told people is that hyper-Bitcoinization already began with Ordinals, because Ordinals is what created the convergence where we all came back together in BTC. And like, let's be honest, the main motherfuckers running that shit, running the show, are BSV people. Ordinals wallet, Unisat, OrdSwap, the first on-chain exchange with partially signed Bitcoin transactions. So like, we already came together. We already like, we're moving forward, but we need hyper-Bitcoinization now, guys. It's urgent. And hyper-Bitcoinization for what? In my opinion, Super, is not for privacy, because privacy, in my opinion, has already been solved. We have the protocols, right? We have, and like I said, we have solid infrastructure in Monero, dude. Monero is so fucking amazing because as a community, they have the most hardcore adherence to the false ethos that I've seen in my life, man. When I go to their conferences, it's like I'm watching a bunch of like it's like a monastery, man. Like, everyone's so humble and everyone's ready to tell you what could possibly be wrong with Monero before they could even ever desire to sell you Monero. Do you know what I mean? Like, there's that humble, dude. Like, it's just the ego stays at the door and they walk in and they just, the free and open source software ethos is just there. So we have Monero and we have other privacy coins. But what I think we need most, man, is a truth machine, the book that they can't burn. You know, that to me is, in this age of censorship, that is the most important thing. Otherwise, we're not going to know who to trust on the internet. And we can easily be Sybil attacked. We can easily be psyoped into going into war with each other. Like, a lot of what I see happening is, excuse me for my rant, but I have to, man. This is my first interview since this supposedly maybe World War III started. How are we to know that they're not using deep fakes to piss one side off against the other? And maybe I wouldn't be surprised as if in the future researchers or whistleblowers come out and they're like, yeah, on this side, they created this deep fake that caused these guys to react in this following way. And on that side, they use this deep fake that caused, I bet you anything that's probably happening. So like, when I talk to privacy enthusiasts, I'm like, bro, yeah, privacy is badass, bro. But do you want to fucking hide forever? I don't want to live in a world where I want to hide, guys. I really fucking don't. I want to live in a world where tyranny becomes ever more costly and liberty, freedom becomes ever more profitable, man. And I think that is what Satoshi gave us. Satoshi gave us a capitalist meritocracy of value, a truth machine where we can like actually figure shit out. And the fact that you're here, Super, and you're like being so generous, to like share with us what you guys are working on. To me, man, like what you're doing is extremely important because you and Robin Linus are leading the way into an awakening with the vast majority of the Bitcoin world, the Bitcoin universe, the SHA-256 world, where people are going to understand the importance of what I just explained, the importance of Bitcoin as the truth machine, man. Because that was like, let me be completely honest with you guys. When I saw the Civil War happening before my eyes, I was like, holy fuck, we are being psyop, man. They're dividing and conquering us as Bitcoiners. And I'm like, shit, they're using our rhetoric. They're using libertarian rhetoric and the Fed. They're using all this rhetoric to like, oh, so obviously we all just came out of like the Ron Paul revolution, the Lovolution, and we're like, well, fuck it. Sound money. So definitely that's why Roger Ver right away was like, yeah, we need money as cash. And then you have the core devs. Oh, we need, digital gold, right? The focus was on the coin aspect of Bitcoin. And then the Monero guys were like, well, if we're going to do this shit right, we should do it right, not try to fucking, do this half-ass. And so then, but then it was like, we got so caught up with the coin aspect of Bitcoin trying to become Monero that we're like, now it's like, wait a minute. And to me, it was like, the moment was like, wait a fucking minute. Like, what did Satoshi give us with everything? And my discovery, again, is that he gave us a shit ton more, man. In my opinion, he gave us a new internet. And he gave us the book of life, to be completely fucking honest. He gave us the book of life, man. And this is, in my opinion, what tyrants hate the most. Tyrants hate to be kept accountable, man. So this is the thing, man. Like super straight up, man. Tyrants, they'll use privacy. Oh, fuck privacy. Yeah, because they like privacy too. But when we talk about a truth ledger, a global truth machine, the book that can never be burned, and then we put everything out that is public, because in my opinion, this is my definition of like how I see this is they're just different tools, right? If I want privacy, I'll use the best privacy, right? Monero, right? Monero is the best privacy. My personal life, privacy. But in the public world, in my public life, I need a truth machine. I need to hold motherfuckers accountable. I need to hold the news accountable because of fake news, right? I need to hold governments accountable, right? That's what we all need. In the public space, we need a truth machine. In the private space, we need a machine that protects our individual sovereignty. So that's my rant. I'm done. What are you guys' thoughts on what I just said?
Yeah, Wright, you want to go first?
Oh yeah, thanks. Yeah, I do. Yeah, thanks. Yeah, for me, I think it's a lot of people in the crypto space. I would say, I think I have some, if not even in an elevated level of frustration about, it's like, hey, we are working on this bit side of Bitcoin, while seems like that the world is burning. It's like the dog meme, right? We're trying to drink coffee while the room is on fire, and we are saying, hey, is this fine? But of course we can only do our own part. We cannot, that's why I like the Bitcoin, because it's like one stone kill multiple birds, right? First, you're talking about the immutable ledger, right? Because if you want, a lot of times the best tool to fight, let's say, corruption, is just transparency, right? It's the best tool to fight, let's say, infection. A lot of times, just sunlight, right, to expose more. For example, you and me, we are here, we are paying tax, and we just send billions to foreign aid. I don't know I don't know where the money ends. I don't know. Maybe military. I guess most of them went to some kind of military industry complex instead of the people who really need the humanitarian aid. I think that's one thing. More accountability is definitely make the world actually a better place. That's for sure. The second thing is money. Our money is broken. Seriously, I don't know, the inflation. I think even before COVID, we can, as a Bitcoiners, we are already theorizing about all it's hypothetical, but now we know, every time I go to, fill my gas, buy some grocery, I'm like, what is this? We can also, it's not something theoretical anymore. In some other country, remote, like we can theorize about. Now it's actually happening everywhere, pretty much. So, I think a lot of also censorship thing, if we can have something very permanent and very hard, I wouldn't say impossible to censor. I think, the Bitcoin to me is one of the few. It's only tool that I can think it can, if not solve, at least alleviate, help us, give us tool to solve all of the fundamental problem that humans now face. I think that's why I wake up every day. I feel, as being 6 years, every day I'm feeling excited about this. I think that the unfortunate thing about, what you talk about, the civil war, the division, is I think a lot of people in the crypto, BTC, BSV, BCH, they have I would say a lot, I would maybe say like 90% of our goals or even, ambitions are the same, hold government accountable, sound money, but we just have different opinions on how to achieve those goals. I think then we don't have to, fight each other. We can or learn and then let the market decide, which one is the best way to achieve the goals we probably share. I think that's just my understanding. And that's also thanks for the opportunity. I think a lot of time we have shared more than what, people on Twitter think what we are.
Awesome. Thank you, Xiaowei. Appreciate it. Super.
Yeah, well, I big fan of privacy and of Truth Machine, and my hope, a big desire for me is to have them both in the same protocol. So you can only have just one sign back there behind you that's for both. That would be really cool. So it's one of the things I'm striving for, is to make it so that you can have Bitcoin and have it be both truthful and honest, and also be have a privacy on it, so people can't see what you're, who you're buying stuff from or how much you're buying it for. That'd be great.
To be honest, Super, I don't think that's, in my personal opinion, is that I don't think that's ever going to happen. I don't think the game theory is set up for that to ever be possible, because a truth machine has to be by default transparent and open to surveillance, which is antithetical to privacy. And just the nature of privacy and anonymity is in itself antithetical in a lot of ways to, well, it just makes it more difficult, right? To going viral, right? And in the attention economy. Sure, you could. I'm not saying you can't, but if you're competing with protocols like a Solana, like a BSV, that can scale rapidly and that are not concerned with privacy, right? Because they're more concerned with interoperability, scalability, cost effectiveness. Like Xiaowei just pointed out, like BSV is like how much, like 0.000001. Like, fuck, man. Like, how can you compete with that is the question. Like, so the thing, what I'm trying to say is, they're antithetical, man. Honestly, Super, my opinion is that you're going to have, and then the privacy community, on the other hand, they're about all about the free and open source software ethos, right? They are going to be focused on making sure they have their own meritocracy, which is not one of proof of work per se, although they use proof of work, but they emphasize in their governance, first and foremost, is the peer review process, the FOSS ethos, which is the verifying of each other's work and making sure that everything, is stress tested, right? Like making sure that there's audits, right? And then they're very conservative and they'll take their time studying everything and they'll figure it out. They'll figure the best things out together. So that dynamic of private by default, like true privacy, I don't think that could ever happen on Bitcoin. What do you guys think? I don't think that's ever going to be able to be possible, because there's always going to be the notion, and this is the main thing, one of the aspects of the Civil War, right? That Bitcoin in its original design, section 2 of the white paper, is a chain of digital signatures. It's almost like every transaction is a contract out in the open, right? The truth machine, the time stamping time machine. So, whereas with SegWit, you remove the witness onto an extended block. So you in BTC, you're taking initiatives to, like you guys use the language, remove the on-chain footprint. Fair enough, but you're always going to have an on-chain footprint. So what are your guys' thoughts on that?
Yeah, Super, you want to go ahead first this time?
Our world is filled with paradoxes, with things that seem mutually contradictory, two things that can't seem to both be true. And yet I've found in my life that you get the most happiness when you grab both of those two opposites, both of those things in a paradoxical level, and you run full speed toward both. And so that's what I want to do. It may seem paradoxical to have a blockchain like Bitcoin that is both fully open to public view and where everything is accountable, and also add privacy to that. But I think that there is a boundary between those two things that I'd like to glide along and see if I can't find something beautiful there at the boundary between publicity and privacy.
All right, so here's the way I've been able to embrace both is that Bitcoin content can be private and disputed publicly, right? Just like it is on the internet now. Content can be private, but the coin aspect of Bitcoin itself, the coin aspect of Bitcoin will never, ever be anything like a Monero or a pirate chain. And if someone is watching this, and they're in a place with conflict in the world, I would tell you, and you're scared of being of financial voyeurism or like tyranny within whatever country you're in, I would say don't use Bitcoin, any of the Bitcoins. Don't use Ethereum. Don't use Solana. Use Monero, right? That number one is Monero. Like, fuck, because they're so conservative, right? And that they take every fucking step. Like, they're very cautious with everything. So I would say use Monero. Monero is in my opinion true digital gold, true digital cash. So the way I've been able to marry, because I've asked myself these questions as well, Super. The way I've been able to marry is like, yes, in Bitcoin you can have both, but you can have it in that the content is private, and like in BSV they're using many different types of zero knowledge at the same time on chain for content, but the ledger it's transparent. So the coin aspect of BSV is always going to be transparent. Xiao, am I wrong? What's going on? Did everything that I say, was it wrong? It's cool. Tell me if I'm wrong. What are your thoughts, Xiao, on this?
Okay, I think it's not a technical issue. Is this I think a difference is more like a philosophical one, because everybody, I think when you talk about Monero, people talk about privacy, which in Bitcoin SV land people more call it anonymity, because that's the difference is, do you want nobody to be able to see these transactions, or you want to have the law enforcement to be able to see, but everybody else cannot see? So that's a big difference, right? So it depends on the definition. What do you mean by privacy? If you just follow the latter one, the second one, I think that Bitcoin is already very good in terms of privacy, because on chain you only see the addresses, and if you don't ever reuse them, and you have a lot of other ways to anonymize yourself, then you are for regular business transaction, it's very, very private. That's also where the scaling comes from, because all of these techniques, right, at the end of the day, you're hiding in the crowd, right? No matter how you mask yourself, or if you're only, let's say only 3 of us, right? How much privacy you are going to get by hiding in this small crowd? Versus if you have scale, let's think about the whole internet, runs on Bitcoin, at least the financial transaction. You have billions of transactions, every single block. How hard it will be to identify, to track. Even you want to monitor all these transactions. It just that even for state level actors, it's very difficult to justify this economically. It's always, if you have a serious crime, you can invest a lot of money, efforts to track. But just for regular citizens, if you have billions of transactions, I don't think the government is going to, afford to have that kind of capability to monitor all of this at the same time. I think that's why scaling is not only a technical imperative, but also from privacy point of view. You also want to scale as fast as possible, as what you are saying. We cannot wait another 18 months. We have to do, things as fast as possible to bring to us to the end of the target we want to reach. Not only we want to reach them, but we want to reach them as fast as possible, so people can benefit from Bitcoin.
I agree. I agree. Section 10 of the white paper, right, gives you privacy, and I agree with your definition as well in making that distinction between privacy and anonymity. But then I would like to make even another distinction for the sake of the audience and everybody watching, that there's a difference between obfuscation and encryption as well, and that some privacy techniques, like Xiaowei explained, they obfuscate, whereas some other privacy techniques, now they're anonymous because now it's not obfuscation, it's encryption, right? Like ciphertext, and you're getting into like homomorphic encryption, and
that's my next article actually.
Really? Watch out! Okay, watch out. What do you mean? So you're gonna give us the alpha? Give us the alpha. What's going to happen? Don't tell me you just unlock full homomorphic encryption on Bitcoin.
Yes, on Bitcoin. It's our next implementation. Actually, I'm writing an article, so probably tomorrow. Yeah, it's you just hear you about this. It's almost a spoiler alert. So I'm happy to share the work.
Well, this is not gonna. I mean, this is gonna go to some editors, our beautiful editors, and our editors are gonna edit this. So this will, by the time this video comes out, it's gonna be on sCrypt.io, the alpha. So make sure when you've done finish watching this, go read that alpha. That sounds really fucking cool, dude.
I think that's our mentality, our philosophy. Bitcoin is, let's say, the privacy is never like a binary thing. To me, it's a spectrum. So you have this, by this default privacy level that Bitcoin already give you. Don't reuse address, don't, social address with your real identity, firewall. If you have even more requirement for security, right? For example, you are like, let's say some dissident, in some oppressed regime, you want to even have even more, and then you can use more cryptography, right? More technique enabled by the Turing Completeness of Bitcoin to enjoy this benefit. Zero knowledge, homomorphic encryption, confidential voting, all the oblivious transfer. You can all use this kind of for additional privacy. But usually you have to, it costs more, right? Nothing comes for free, right? You can enjoy those privacy, but at a much higher cost. But the default level is whatever Bitcoin already offers, which is good for most day-to-day business transactions, right? For example, I want to buy some, stuff on Amazon, I can pretty much use Bitcoin. I see no problem. I probably don't have to use, Monero. That's why I choose to work on Bitcoin, because to me, it's a more mainstream market, right? So if you want to change the life of 1 billion, 8 billion people, or you want to use, Monero, my guess, you don't have to agree, but it's probably will always be a niche, right? I don't see everybody using Monero. Can you use Monero to pay some bills? What if that's a dispute? You cannot even trace back, right? You have view keys. You do have view keys, and you can have like systems of escrow, like Bisq.network, right? Like Agora Desk, like Local Monero. So there are assurance contracts. There are things that can be done. Yes, but the game theory. What's the market size for that? is always going to be much less than the mainstream. That's what I'm saying.
I agree,
think I wouldn't-
especially okay, because like most people are when you say those things, pardon me for cutting you off, but when you say those things, most people are thinking about just the coin aspect of Bitcoin versus the coin aspect of Monero. But then when you talk about, and this is what this conversation is about, Bitcoin's computational power, then it's a whole, okay, now it's a whole different fucking category that Satoshi gave us.
Monero can offer that.
Okay, Monero can't offer that. Exactly. That's why, you know, during the Civil War, I was like, wait a fucking minute. We're focused. We already, okay, Monero's getting started. Cool. 2014. What the fuck are we doing here? Like, what did he give us? And then the question was like, let me look at these opcodes. What's end sequence? What do you mean we're going to get rid of end sequence? Opmo, opdiv. What do you mean we're getting rid of these? Wait, I want to play with them. I want to play with them. I want to play with them. And I've had to go to this like the forbidden place in crypto to go play with these things called BSV. It's like Antarctica, right? It's like no ships can go there, right? No ships can go there. It's delisted. It's like there are helicopters. You can't go there. If you go there, you're like, how dare you fucking go there?
Edge of the earth.
Huh?
You're far off the edge of the earth.
Yeah, you just can't go beyond the ice wall, right? So it's like I've been in Antarctica playing with this like fucking technology, and then I come back and I'm like, and then like we're in New York City now because you know Casey Rodamore gave us like a little bit to arbitrage data. So guys from Antarctica, you know, they go into New York City, they can't do much. Transaction fees are high, so they start selling Gucci bags, right, in Fifth Avenue, right? I mean they're opening up. They can't open giant nightclubs, but they can open up a little nightclub. And it's the first nightclub that New York City has ever had. So obviously there's a fucking line down the block and the people are starting to like, hey, New York City, like fucking city council, like let us have more fun because we've never had fun. And it's so much fun. And then everybody forgot about Chicago, Ethereum, right? Everybody forgot about Solana. Everybody just came to BTC and we're like partying. Yeah, it costs a shit ton of money. And I find myself like making drinks for people in a place that never had any fun for fucking ever, right? Since the Civil War, right? Like, no nightclubs, no art galleries, no theater. All of a sudden, it's like it's limited, right? But then all of a sudden, it's like we have Super, and he's like, look, guys, to New York City, like there's crazy technology that has been worked on behind the forbidden walls of Antarctica, but here I am, like here's the computational power of Bitcoin, and now everybody's like, what? Like, and then the question is like, why haven't we been able to play with this whole time, right? And it's in everybody's mind, like, what the fuck happened? Why was this shit kept away from us, right? And you can answer that question. Read Bitcoin history, figure it out. I have my opinions. Everybody has their own opinions, but we're at this point now where we're like all excited because, like Antarctica, forbidden technology is now accepted, is beginning to be played with in the metropolis that is BTC, you know, in the Fifth Ave that is BTC. So then you have people like Casey Rodamore saying like, oh, we should increase the op return size, he said this week. He also said we should increase the transaction size. And then we have people saying, well, maybe we should also re-enable the OpCat. Like, what's going on, guys? Help me make sense what the fuck is going on here, because this all sounds really exciting. What's going on?
But are you? It seems like you're wondering why there's suddenly a lot of activity on Bitcoin. Is that a fair way to rephrase?
Yeah, man.
Question?
Like, because like, okay. I have to ask. What happened in BTC? Where like we had a civil war where we were told to not do things on chain, that we were forbidden to do this, forbidden to do that. You know, you take away opcodes that Satoshi gave us, and then all of a sudden there's a 180, which now BTC is sounding a lot like their plan for scaling mirrors BSV, the forbidden place. What's going on? What's happening? Super, help me make sense. What's going on? Please.
Yeah, well, I guess Perhaps I don't see things the same way you do. The same way you do. I don't think there was a period when nothing was happening on Bitcoin. I've been working on Bitcoin during the whole period when you talked about nothing happening.
Well, let me make one second. On chain, happening on chain, just nothing happening on chain. You know, now we are.
Sure.
That's what I meant to say. Not, of course, we had like RGB, Lightning Network, Rootstock, Stacks. Like, there's a lot of things outside of Bitcoin, like outside of the main chain, outside of the actual blockchain. But it's the emergence of an on-chain economy and an emergence of embracing Bitcoin's computational power within BTC that has me asking, what happened? Why did this happen?
So one of the you talked about how less is happening on chain, and I think part of the reason why a lot of development moved over to Lightning was because it opened up, it made programming fun again. Like Lightning introduced a lot of constraints that were attractive to developers, and trying to think of ways to navigate around those constraints. And so a lot of Bitcoin companies shifted their development efforts toward doing things on Lightning. Somehow, in the midst of all that, Taproot also got activated, and that part perplexes me a little bit, because it was like, we're also going to expand the functionality of the base layer when everyone was focused on Lightning. But it happened, and it took a while. It took a couple years for some of that development to come back to say, okay, what can we do with these new Taproot tricks? And so yeah, I think Lightning is part of the reason why it didn't happen quickly, is because Lightning was just not fully explored yet. No, it probably still isn't, but it's a lot more so now. And I think people are running into the limitations of Lightning, and that's why they're looking to stuff like Taproot and maybe stuff like Covenants or Upcat in order to get around some of those limitations. But yeah, I really do think it had a lot to do with a lot of Bitcoin developers just found a new field of exploration in Lightning and started working on that. And thus their attention was taken away from trying to improve the base layer.
But see, that's why, like, I was a big blocker during the Civil War, because like my Bitcoin is not your science experiment. That's literally how I feel. Like, leave Bitcoin alone. Leave it as Satoshi gave him to us. You know, let's experiment with everything. Let's increase the block size. Let's increase the size of the script. So let's talk about that a little bit. Script size, right? When you compute on chain in BTC right now, you're computing 32 megabytes when you do compute script on chain in BTC. Sometimes it's 64, right? When is it that it's 64? I always forget exactly when it is 64 on BTC. There's once in a while it's 64, right? Okay. 64. So in order for you guys at BitVM to actually do more, you guys are gonna have to, sooner or later, in my opinion, increase the script size, which means you guys are gonna have to increase the block size. Am I correct? Am I correct in that assessment? In that logical conclusion?
I don't think so. And part of the reason is that because we break down every program we want to run into its individual components, into the individual logic gates that it would pass through when it's running through an actual processor, those things are pretty small. They're only, I don't know, maybe like 12 lines of script, and so they're well under the limit of the script operations that we're allowed. I mean, they're like 1%, less than 1% of the capacity we have. So since you're only ever executing one at a time, you never need a lot of space in order to do what we're doing.
What if BitVM takes off and a lot of people want to use it? What happens then? Don't you have to raise the block size limit? No. Even each BitVM transaction is small, right? Let's say one.
Yeah, each BitVM transaction is small, so that for every,
a lot of people use it at the same time.
Right.
What's going to happen? You want this to happen. You want people to use BitVM, right? So I'm curious.
I want to use it. If they want the same things I want, then I welcome them to use it too. But different people want the Bitcoin for different things. Some people might just want to buy Bitcoin, put it on a cold card, a cold storage wallet, and not look at it again for 10 years. And that's fine. They're not gonna want to use BitVM. I don't expect them to. Some people just want to throw it in a Lightning channel and pay people, zap people on Nostr, and then take their money out, and that's fine. They don't need BitVM. But if you want to do like some of the, if you want to do the stuff that we've thought of for BitVM, like doing a bridge into a sidechain, or finding some way to run a tornado cash clone, or maybe doing doing covenants, that I think BitVM can help enable those technologies, and I want to use those things, so I'm going to use it. But not everyone will. They're not all interested in that.
What I'm saying is I mean, you want people to use it, right? So I'm asking if let's say 1 million people want to use it, every hour or every day, what's going to happen? Then the block size be a limiting factor.
I don't think your question needs me to want people to use it, because that doesn't concern me. If I can use it, then I'm happy. I don't care if 10 million other people use it.
Okay, sorry. Okay, I thought that you want more and more. The more people use it, the merrier. Okay.
Yeah, that doesn't concern me. I want to use it, and so I'm making it so that I can use it. If other people want to, that's great, but that's not a goal of mine. But yeah, if a lot of people did choose to use it, if it increased the number of transactions per day by 1 million, because it was very popular and everyone wanted to do chess on the blockchain or whatever, that'd be a problem, because we can't do 1 million transactions per day in Bitcoin, so it wouldn't work.
Why not?
Well, because there's only a certain number of transactions that are allowed on the blockchain per day.
But why can't you just increase the block size to allow more?
Because I think that makes it difficult for people who are running nodes to run them, and I want to keep that. I personally want to keep it easy. I want to be able to run a node.
Okay, so you're trying to. Okay, that's okay. So you're going back into but I mean, to be honest, man, dude, a full node in BTC is a do-it-yourself block explorer, man. I mean, I'm a miner, bro. I'm a real node, in my opinion. I protect the network. My transactions extend the actual ledger. Like, what's a guy with a window gonna do?
Stop you from creating coins.
How?
Well, by rejecting those blocks that create those coins.
But I have a question, man, because this always mind boggled me, dude. You're trying to mirror some sort of like social democracy, where you're saying, oh, we're giving people power by giving them like full node status. But I can right now, I can fund 100,000 full nodes, 500,000 full nodes. How's the network not going to think that it's 500,000 different people?
Sybil attack.
Yeah, it's a Sybil attack.
Mm-hmm. Well, I don't care what other people think. I just care what I think. And if 500,000 nodes say that this block, is allowed to create, an extra Bitcoin,
right? But they're all me.
I only care what my node says.
But they're all me, and I'm drowning you, and you don't have, I'm drowning you in the noise, right? And now
I don't think so, because as long as my node says, this extra BTC isn't real, then I just don't accept it. Even if even if I think 100,000 other people say it's real, I'm going to say it's fake.
Interesting. Yeah, the only way to secure the network is through proof of work, in my opinion. I never understood this argument. Being honest and respectful here, to be honest, this doesn't make sense to me. Still to this day, it doesn't make sense. Szabo, you wanted to say something? Yeah, for me, if that's a ledger, right? Think about it. That's why I think about it. When I first started tinkering with Bitcoin, I got the mastering Bitcoin book from Andreas and Navanis. The first thing I do is run a full node. Okay, so what I notice is if I turn it off, seems nothing happened. You see what I mean? So if I'm doing something and then I stop doing it, and the world it doesn't change. To me, that means the net effect is marginal, to say, at the most marginal, right? So that's the way I interpret it. And also, if I have a ledger, I can only read, but I'm not able to write to it. That doesn't give me power to let's say, reject or accept transactions. But I think that's
not a technical issue. It's more like a philosophy
Yeah, it is.
difference.
It is a philosophy. Yeah. Super.
Sorry, I was just blowing my nose. Yeah, there's a lot of philosophy that underlies Bitcoin, and one of the things that I think is great about it is that we don't have to agree on everything. It would be a really boring world if everyone thought that everything Super Testnet thinks is true. But we live in a world where we don't all have to agree. We can have different philosophies, but at least we have. At least Bitcoin allows us to transact with one another if we at least share that philosophy in common.
Right. Well, like in Austrian economics, is founded on the apodictic principles, states of affairs that can't be otherwise. And like Szabo didn't give you actually philosophy. In my opinion, he gave you an apodictic truth that if turns off his node, nothing, the network is not affected one way or another. Whereas as a miner, I have a automatic feedback loop into the market by running the hard metal. I know exactly how I can best help programmers like yourselves, process transactions, maybe make the transactions cheaper, maybe help you do simplified payment verification for some sort of thing that you need with BitVM in the future. That's the type of mindset that I have, right? It's different. But it's based on an apodictic principle, like the law of non-contradiction, right? Like it is, and it can't be anything else other than what it is, right? And the fact is, like, that's what Szabo pretty much said. It's not really a philosophy. It's a reality that if he runs his node and he turns it off, it's like nothing happens to the network. What you're left with is just an argument based on politics.
It seems to me that if Szabo turns off his node, then the network is affected in one way, which is that there's one less person on that network. And that has some consequences for him. For example, if he was running a node and you tried to send him a counterfeit coin, he could detect that and say, I'm not accepting this. But if he departs from the network and then you send him a counterfeit coin, he's got to trust somebody. He's got to say, okay, I'm going to either trust that this coin you sent me is valid, or I'm going to ask someone, hey, is this valid? And then I'm going to trust them. Because he's not running a node on the network anymore. So he's not checking if the coin you sent him is valid.
Right, but isn't the proof of work dynamic? And so, right. 1 second. The proof of work game theory is one where like miners spend energy that they will never get back, and they've shown me that they've been honest in securing the network. Therefore, I can have a high degree of certainty that indeed they will continue to protect the network moving forward. Szabo, I'm sorry, you were going to say. Sorry for cutting you off.
I think that's the entire section. I believe it's section 7 in the white paper, specifically designed to solve the problem you just mentioned, called SPV. I think you must be very familiar. So basically, I don't need to run a full node. I can just have whoever sending me Bitcoins, they also need to give me the proof that this is legit through SPV. If I check SPV proof, I have a very high chance of if he's ever deceiving me by sending me some fake coins.
You know what's really fucking interesting? Now that you mention that, sorry, 1 second, Super. Before the Civil War, there was a project, I can't think of the name right now, that was sending Bitcoin through ham radio. And they discovered that the only way to send Bitcoin via ham radio, in other words, you don't need the internet, just ham radio, it was through SPV. That fucking blew my mind. I'm sorry, you were saying, Super?
Yeah, the SPV proofs are great, and one of the properties of them is that it seems to me that they're only good until a certain expense. For example, let me give some context for that remark. When you use an SPV proof, you're checking how much work somebody put into saying that this coin was mined in a certain block, or that this transaction was mined in a certain block, and it costs a certain amount of work to do that. So let's say that it costs $15,000 to mine a block. That means an SPV proof is a pretty good indicator that a transaction is valid if it costed $15,000 to produce the block and produce the proof, It says this transaction is valid. But once you go over that, once someone is sending you a coin for $50,000, then you look at their SPV proof and say, well, it costed you $15,000 to create this proof, or it costed someone $15,000 to create this proof. I'm not going to trust that proof for an amount that's more than $15,000 because they might have lied. They might have spent $15,000 to produce the proof, but it's not really part of Bitcoin. So that's one limitation of SPV proofs. They're wonderful and they allow, but they are only good until a certain amount of money is being transferred.
Can you, in this case, wait for more blocks confirmations? For example, if I'm buying a coffee, I'm very comfortable with so-called, zero conf, or some people call it instant transaction. But if I'm buying a house, I would rather wait for, if not one day, or sometimes if paranoid, I wait for 1 week or 1 month. For me, security is not binary. It's always like economic, as what you just suggest. If it's below, 50,000, and it costs the attacker to 50,000 to just give me some fake $1 bill, I don't think it's going to last long. So if in scenarios which I have high value coins, I just have to wait for more confirmations, blocks to be buried before I trust the SPV proof. Basically, I'm saying is the SPV proof is configurable, depends on what's the value I'm accepting. It's always economic, the security level, because end of the day, everything in our world, as you said in the beginning, there's nothing that's 100%. It's always probabilistic to me. There's no infinity. There's no 100% in real world. I think for me, it's always about economic and probability.
Yeah, I think if you were going to do like $100,000 transaction and blocks costed $10,000 each to produce, or SPV proofs costed $10,000 each to produce, then you could say, all right, I don't need you to just show me one block, an SPV proof that the transaction was included in one block, but I need you to show it was that block was built on by 9 additional ones, so that the cost of producing that SPV proof would exceed the value you'd get by cheating it.
Exactly. Yes.
That's beautiful. So you guys agree? Hey, you guys agree on something. I'm gonna have to go back and rewatch the whole conversation because
I think we've been agreeing a lot.
Yeah, that's what Mr. earlier said. Probably 90%.
My children are working together. Yes. Come together, Bitcoin. Be one united Bitcoin front again. Become a symbiotic relationship. Please. It's already happening. Market is driving us in that direction, right? With Ordinals. So let's just keep going. Anything else you guys want to talk about? Ask each other. I would love to just be a fly in the wall and just hear you guys talk about Bitcoin Turing Completeness.
Well, I've got to get going because I would like to go eat, and so that's the next thing on my plate, so to speak. Awesome. Well, what's up, Szabo? Anything from you?
I'm a techie guy, so it's great. Always we can somehow geek out the thing, but I'm really curious to see how you guys solve the potential challenges of first to allow multiple parties, bigger than 2 parties, and things how to make this non-interactive, the BitVM. I'm really looking forward to potential solutions because those are really will be another level of breakthroughs. I'm really looking forward to come up with. I will keep an eye on it, and best luck. Thank you. All right. Thank you. Guys, we need it.
Guys, thank you so much for both of your time. And will you guys be open to doing this again as things move along? And maybe bring Robin in, bring more people in, just like let's have a cool conversation. Let's figure hyper Bitcoinization out. You guys cool with that? Yeah, I'm cool with that.
I'd love to.
All right. Beautiful. Thank you, guys. All right.
All right. Thank you. And
time to go.
Soon. And let's talk again. Okay.
Peace, love, and anarchy.